How's it going, guys? It's Jason from the General Cone Repair Channel. We're just here today. I need to do a calibration on a Tutenauer EZ10, and seemed like maybe it's a little bit of a long process to do live, but I figure, hey, we'll give it a shot. Maybe there's a couple things that, for those of you that are learning how to do autoclave repair, there might be some things that you hear or see today that might be beneficial to you. And what we're going to do is we're going to just try to get through as much of the calibration as we can, and we're going to show how to use some of the special tools and how to do certain things with this autoclave that are going to possibly empower and just help you to understand them a little bit better. So this unit, what's happened is the temperature has been reading a little bit out. I believe it should be 270 or 272, something like that, but the temperature's been 275. So I want to walk through hooking in the test kit here. This is a test kit that we have. It's the Smart Kit from RPI. This is TUK 108, and it comes in a little pistol case. It has several things in it. There's a gauge. There's a this is a temperature simulator. This is a test point board, and then we also have like a little tweaker here for potentiometers. That's one of the tools we're going to be using today. The other tool we're going to be using is a multimeter. We're going to be using some wrenches and some hemostats. Inside the RPI book, there's a diagnostic smart kit, and I think, if I'm not mistaken, you can actually go online and actually find this the soft copy of this book from RPI. And what you have to do is just spend a little bit of time in here. Again, we're going to leap into what we're doing, but there's a lot of good information here. There's some good nomenclature, some pictures. RPI always does a fantastic job of taking complicated processes and just really breaking them down and giving really quality, useful information. And not all these things are going to apply. In the past, I've actually highlighted some different things that are useful, and that helps me to kind of find them a little bit quicker. I know everyone likes having digital content, but this is great because like just getting a book and like writing in it is going to help you kind of find things that are relevant to your the job you're doing, and you can kind of like stack knowledge from one experience onto another, and this is really how you're going to accelerate the speed of getting these things fixed, as well as you're going to just accelerate your ability to understand what's happening with these units. Because what happens is you have hard problems that are you don't understand, you figure it out, the next time the problem's a little bit harder, and that's how your skill gets better with these autoclaves. So what we're going to do very first is we are going to get this unit set up to run. And one of the first things that we're going to do is we're going to go ahead and put in a pressure gauge. And the pressure gauge, if you want to come over here, Kyle, get my hand off to me. All right, here we go. All right, so the pressure gauge through the kit is this, basically it has like a little memory on it. So basically as the pressure gauge moves up, it kind of leaves a witness of how high it got. So these gauges are really useful because on an autoclave, if you're not watching the where the temperature is, then like as it's happening, the cycle could be over and you don't have your information. So these gauges, again, they're pretty handy, and they leave that witness there. So the way that we're going to read a autoclave piping here is the chamber is obviously right here. Now there's a data plate here. I'll definitely say that these autoclaves it's important to do them right. The chambers are all certified, and I have heard technicians talking about messing with the door, or changing pivots on the door or whatnot. It's important to know that the door is part of the reservoir, or a part of the chamber, and that's a certified component. So the official word from Tutenauer is that you need to send the unit back to Tootnauer for them to do anything related to the door, or if there's any cracks. So like you can't, it's not smart to like weld the chamber or do anything, because if anything ever happened with this and you were the one that you gave them an invoice that you did something that was outside of the legal realm of what you can do, you could actually probably be sued and held liable for hurting people. So we don't want that. So the way we're going to read the autoclave here is we basically have a port coming out of the chamber. All right, that is visible from the inside. It comes up here, and then this right here is a temperature sensor. Okay, and then it comes here to a little bit of a manifold, and basically this is where the pressure comes off, and the pressure goes up, over, and down here, and that pressure goes to a sensor that's a little hard to see. It's right there. So that's the pressure sensor. Okay. So this is from the pressure sensor. And then this one right here is going forward. And this bigger pipe goes here into the reservoir. And that's for your safety valve. And that's also a little air vent valve, has this little pin on it that you pull. And then there's also another another port that comes over here to our solenoids, and this is what controls the venting. And the basically right here is where right here again is where we're going to hook our gauge in. And the reason we're going to do that is because that little component right there is what takes it's a pressure transducer. And that pressure transducer, my understanding of a transducer is that it converts one form of basically converts one reading into another. So this one's going to convert pressure into an electrical signal. And so instead, because we don't have a physical gauge to reference, we're going to go ahead and put in our pressure gauge right here. And that on the kit, it's the Tootnauer, the RPI kit, it just has kind of a female to male there. And that's going to just kind of go right in place. So I'm going to have Kyle go ahead and install that. Here you go. And we'll kind of come over here and take a peek from this perspective. That's being done. My guys, put my men to work here. As I said earlier, you can kind of see where it the access is right there, and then down the bottom there's also a drain. So what Kyle's doing is he's using a backing wrench to hold the manifold as he spins off the coiled tubing there, and that's just going to release. Yep, just got to jiggle it. Just jiggle the pipe a little bit, and it'll come right out. Okay. And then that's going to be a little backwards. There you go. All right. And I had, this gauge was actually pointed the other direction, I think, and I had spun it around. So it's good to be able to actually reference the gauge as you're working on the unit. All right, so we are going to go ahead and I'll just show you right quick here what we're doing. So that is where the test pressure gauge gets put in. And again, that's pretty much what we're doing right now. Trying to not make this super duper hard. The point of this training is really just to kind of explore the basics of what this calibration looks like. So the gauge is now installed, and that is looking good. So the unit does have water in it, and we are ready to go here. Now, the first thing that we're going to do is we'll go and find the part in the manual where we're going to hook in the this board here. Let's see here. So because the first thing is, so this is the main part that we're going to mess with on this calibration. There's a gain zero, a gain pressure, zero temperature, and a gain temperature. So really the pressure and the temperature are the two features on this system that we're really going to affect. And that's what it's going to look like as we hook these things in. So Kyle, do you want to go ahead and grab the thing here, and I'll hop into action. And you guys can comment. I see a couple of people are watching live here, so if there's anything that you guys have for questions, please let me know. Again, this is, I was going to do this training anyway, so I figured I might as well do it in a way where, you know, you guys can have benefit too. So the board here is designed by RPI to have this little thing right here. This just sits right there. And then there's a ribbon cable. This ribbon cable is keyed, and it's keyed right there so that goes up here into the top. Okay, so that just snaps right in there. And then there's also a ribbon cable right here. So we're gonna hook that in. All right, we're just gonna go ahead and get this in here so that we're good to go. All right, so that's in there. Now, let's see here. Calibration, temperature sensor. Connect the simulator. All right, so we're going to go ahead and do the temperature sensor calibration first, and that's going to involve this box. So what it's telling us to do is it's telling us to connect the test board. So we did that, and now we're going to connect the simulator to the JP11 connector. Now what I've learned is that this sensor, it's basically it's right down in there, and it's super hard to see probably, but it's that, I think it's, no, it's not that. It's not that. Oh, okay, well duh. It's the ones with the wires hooked to the sensor. So what I'm gonna do is I'm just gonna take a pair of these hemos and just very lightly pull. Actually, am I leading us astray here? I'm leading us astray. Never mind. Okay, so this is the temperature, this one, because you can't read what the J is. Okay, so I'm going to take this connector off, and I'm going to remove the one that looks just like it, which is this little tiny guy. So I'm just going to do like a single click on the hemos, one click, and then I'm just going to kind of gently wiggle that out. All right? And so now I'm going to take this other one, and I'm just going to do, again, one click on the hemos and get it down in there. And these hemostats are really handy for getting in there. So I'm just going to take this down there. I'm going to line it up, pop it on, and boom, take the hemos out. So now this is installed. So we're going to go ahead and plug in our unit. All right. The power cord for this unit, or power plug, is right down here. All right, let's see what our procedure says here. So we connected the simulator to JP11, and then connect the negative probe of a voltmeter TP25 to the positive probe on the test board. So we'll take our voltmeter and let's see here. So we're gonna, let's see. Negative probe of the voltmeter to TP25 and the positive TP26. So negative TP25. So I'm going to use that to push down there, TP25, and then TP26. Okay, so there we go. All right. Plug the sterilizer into the source and turn the sterilizer power on. Using the trim pot, adjust pot 4 until it reads negative 5.1 millivolts DC. So we're going to go over here to volts. And right now, that's interesting that we're at 164. And that's because I missed step 3. On the simulator, select 32 degrees Fahrenheit. Now, so you can kind of watch how this works. What this is resistance, okay? And this resistance inside this box that's connected through these wires is telling the machine that based on the temperature on the thermal probe, this is how hot it is. So as we move temperature, okay, and the resistance, okay, it's simulated, it's going to give us a different millivolt reading coming out. All right, so this is how this stuff works. So that's why a little component can cause the machine to know where it's at. And that's why sometimes when you have a problem where like there's not a correct pressure reading, you would have a basically have a some sort of like an electrical component that's bad. Now, right now we're at 5.1. We can try to get that one a little bit better. So in here, there's 3 potentiometers, okay? They're blue. There's that one's potentiometer 2, that one's potentiometer 4, and that one is, what is it? 5, I think. Or you can look inside your book, and there is a, where was it? Boom. Okay. Pot 2, 4, and 5, okay? So now this is going to tell us what we're messing with here. So, okay. Using the trim pot adjustment tool, adjust pot 4 on the Agent 3 board so the voltmeter reads negative 5.1. Okay. And so pot 4 is going to be the one in the back. So I'm going to go ahead and move this off to the side a little bit. I'm just going to take this and we're just going to adjust. So now it's at 5.0. I'm just going to put it in there. And it's not, I mean, it's totally not going to take that much at all. So I moved it actually just like I barely moved it, and it just went to 5.2. So, and also note that it should be that negative reading is what we're looking for. Oh my goodness. All right, so I'm turning it back just to, no? Okay. All right, and 5 probably would be good enough. A little trick is to tap the potentiometer after you make the adjustment in case there's some sort of maybe it was kind of like stuck a little bit, and by tapping it, you kind of cause it to kind of settle into the position it's going to be in. So now we're at negative 5.1, which is what we wanted. And now on the simulator, we're going to select 273 degrees. So that's all the way over here. So we're going to go, okay. All right. And connect the negative probe of the voltmeter to TP1 and the positive probe to TP7 on the test board. So negative probe TP1, positive probe TP7. So we're gonna go ahead and, so positive TP7, and this is where sometimes having a little pusher is gonna, so you push this down, that opens it up, and then that's going to click on there, and then the positive or negative to TP1, and we'll reread it. And so as you're noticing, I'm reading something, I'm doing it, I'm going back and rereading it and figuring, confirming that I get it right. So negative probe TP1, positive probe TP7. There we are. Now, connect the negative probe. All right. Using the pot adjustment tool, adjust pot 5 on the Agent 3 board so that the voltmeter reads 2.385 volts DC. And we're right at 2.388. So we'll try it. So pot 5 is the one that's on the bottom. Okay, so there we are, pot 5. All right, and that's the gain temperature. So we did the 0 temperature, now we're doing the gain. Gain is a function of, like, if you have a sensor that has a high level, like 0 is kind of telling it what the floor is, and then gain is telling it what some correct position is at a higher level. And between the gain and 0, that's how a machine knows where it's at in the middle. So just keep in mind, like, these affect one another. So we're going to go ahead and adjust that pot 5 for 2.385. So we'll go right down here. And again, just so gentle. That's going higher. Okay. Oh, too much. And it takes like a little second to catch up, so. All right, we might. Tap it a little bit there. All right. Okay. So we might not be able to get there. It's hopping just right on it, right past it. So if that's the case, then, that just might be what you got. Just get it as close as you can. So right now we're at 2.384. Another thing that's important to remember is, like, multimeter does have some error in it. So multimeters can be like plus or minus 5% or 2% error. My multimeters, I don't calibrate them, so there could even be more error than that. But for right now, like, this is just what I have, so it's what I'm using, and it works fine. So this is, so we went ahead and got this step. So if you think about it, we've done the 2 of the 3 potentiometers we've adjusted. Like, this is our adjustment. So now what we're going to do is now it doesn't actually tell us to rehook up the pressure of the pressure transducer of the unit, but we're going to do that because right now we've used this box, we've adjusted the 0 and the gain, so now we're going to go ahead and use our same process. I'm going to we're going to unplug the unit just so we don't short anything out. All right, and I'm going to pull out the little test box here. One click on the hemos. Pull her out. Okay. Get that out of there. And then this is like one of those things where, like, in my life, I know there's certain things that have prepared me for other things, and this is where that game of operation has prepared me in life for using tweezers and hemostats. I probably use these more than some doctors. So that's all plugged back in now. So what we're going to do is find the procedure where okay. This is where we're going to do the final test or final adjustment, potentiometer, basically that potentiometer 2. So now connect the test point board, okay, using the ribbon cable, we already did that. Now connect the voltmeter to test point 4 and 1. Now on these, I think, so test point 4 and 1, it doesn't say polarity. I don't think it cares because we're just doing 500 millivolts. All right, so test point 4 and 1. So I'm going to take it off of 7, put it down here onto 4. All right, and then our reading is 500 millivolts. So we're on volts DC. All right, so we'll go ahead and turn it back on. Have any questions come through yet, Kyle?
Nope.
All right. All right, so here we go. So right now we're at 500 millivolt. We're at 508. We should be at 500. So we're going to use potentiometer 2. And keep in mind what this is right here. We're adjusting. So pot 2, we're adjusting. Yep. And that's, yep. Pot 2, we're adjusting the gain pressure. So this is the pressure. Now, it's probably going to be necessary that we're going to have to screw around with this one as we're using it. So just keep in mind that we're going to do this, and then we're going to see what happens, and then we might have to revisit this. All right, so now I'm going to turn this just a little bit. Oh, just barely. That just jumped around. All right. Whew, man, yeah. You have pretty steady hands for this. These Adjunct 3 boards are a little bit miserable. These are not my favorite design for the Toot Hour. All right, so tap, tap, tap. All right, boom. There we go, steady hands. Woo! All right, now, if the front panel display changes from 0, close the sterilizer door, start an unwrap cycle. If the pressure rises within the chamber to 30 psi, the voltage reading should rise from 500 to 1.5 volts. Okay. So let's go ahead and see what our pressure is here. All right, so we're at 0 psi. So at this point, we're going to go ahead and we'll put a tray in. I don't know if we have a tray. I don't think this one came with a tray. I'm just going to grab a tray. We'll grab a thermometer. That was not the right tray, huh? That's fun. All right. All right, that. No? All right, that one will work. All right, so this is a max register thermometer. What it does is there's mercury in here, and as it heats up, the mercury moves, and then it stays. So it's an old-timey thermometer, but this allows us to go ahead and get an objective measurement of what's going on inside the chamber there. So we'll set this. So I shook it out, and now you can't see the mercury bar. So let's go ahead and close this guy. Actually, I'm going to do one thing that we should do. We should verify the actual the level of the autoclave. I don't know that a lot of people actually know about this one. So on the autoclave case, wherever it is.
That one's over there.
Gotcha. Okay. Let's see. Does it have anything? No. Okay. So here's actually something good to know is that this unit here actually has operational instructions on the top, which is pretty nice. Now, I'm going to have to. Where's the 2-hour manual? Do you have a 2-hour manual?
No, not yet.
No? Alright. Let's see here. Is there. I thought there was a 2-hour manual. Seeing as how my. Because I'm not going to probably remember if it was 12 ounces or what. But anyhow, we'll just run it. All right. This is about autoclave calibration, not leveling, so we'll just send it. All right, so this, when I'm closing these doors, I only ever use one hand. It has 2 handles, but I only use one because I don't want to overpower it, break it. All right, so that's good. What we're gonna do is we'll go ahead and run it here at this, at what it was. So 273 is our set temperature. Sterilization time's at 5 minutes, and then dry time. And that's for this one here, which I think is pouches. We can also do an unwrapped, which if we want to adjust the time to 3 minutes, we can. So the dry time, we'll leave it, we'll actually reduce that just so we get a quicker conclusion to our cycle. Leave them both at 3. And then we'll go ahead and hit start. All right, so now what's happening is the pump is actually, the water pump is pumping water from the reservoir into the chamber itself. And at that point, it'll start heating up, and we'll be able to observe our gauge up here, as well as our pressure right here. Now, let's see. What am I missing, Kyle? Am I missing anything? I'll definitely say something about test equipment. If you ever are using a multimeter, it's important for you to understand what a reading you're expecting to get. And if you're not actually getting that reading, it's always important for you to check your equipment. I think probably almost seems like probably about half the time, I might not have a good connection, or I might not have something hooked up in the right spot. So it's good before you just automatically jump to there being a problem in the machine. You always want to check your test equipment. These are pretty simple, but on some multimeters, you actually have like more than one place to plug it in. You have different things going on where these, there can be errors induced. So just as you're learning, just keep in mind, you might be chasing your tail thinking there's a problem with the machine when really, your equipment might not just be operating well. I'll go ahead and talk about this a little bit while we're heating up, because this is kind of the boring part of what we're doing. Right now, the autoclave is at 72 degrees. That's, if you think about it, okay, that's about what the temperature is here in the room, because it's been sitting here all night, or for, as long as it's been sitting here. So this pressure, what we want to see is we want for the pressure to be to be raising, within probably a minute or two. We want to start seeing that number just clicking up to 20, 73, 74. And what that's going to show us is that the heating element is actually heating up in the unit. If you ever have any autoclave where it's just sitting there and the pressure or the temperature is not raising at all, then what that's going to tell you is that you have some sort of a problem in your heater circuit. So I'm not expecting that to be the issue here, and it will just probably take a while for that to start bumping up. But now this right here is a saturated steam chart that I've printed for the shop. And one thing that's very good to know whenever you're working on any autoclave is that temperature and pressure are correlated. So there's our pressure and there's our temperature. And if you think about it like this, that when you are like cooking a pot of spaghetti at home, when you're boiling the water, that pot is going to boil at 212 degrees, right? That's boiling. Well, the other type of thing in your kitchen might be a pressure cooker. So a pressure cooker begins to actually put pressure on, like it encloses the boiling water, and then we can start to build pressure. So that's exactly what an autoclave is doing. It's basically a pressure cooker where we're achieving higher temperature through pressure. So most problems with an autoclave are going to result from some sort of a steam leak. And so as you can see here, at 212, we're at 0. But then as we start clocking up to like 222, we're at 3.3, 233, 7.3. And then, so what we have here is actually this really cool, it's kind of this really cool correlation between pressure and temperature, so that if, say you actually have a unit where maybe the pressure gauge, we have actually one right over here, this Pelton Crane unit. This unit's only achieving 250 degrees. So one of the questions we have to ask ourselves with it is, or 260, is that, is it an indication problem, or is it actually a problem where the unit's not achieving temperature, the temperature and pressure? So this is where this correlation happens. And this is an area that I think not a lot of dental staff understand. And this is something as service technicians that we can help explain, that basically in order to get to a sterilization temperature of 273 or 274 degrees, we're looking about 30 pounds of pressure. And if you stop and think about it, that 30 pounds of pressure is about a car tire worth of pressure. So that's why whenever we have autoclaves that are running, we want to pay specific attention to see if there's any sort of a like steam leaking out the front or out the back. This particular unit is an automatic autoclave. The difference between an automatic autoclave and a manual autoclave is an automatic autoclave always has a button on it called start. If your autoclave has a start button, you have an automatic autoclave. Now, if you have an autoclave with a knob that you turn around in circles and you go from fill to sterilize to vent to off, that is a manual autoclave. So just keep in mind, this is how these devices are classified, and that's how you know that the type of unit you have. The other thing about the Tutenauers that is unique to them, or not unique, but I mean it's special for them, is they have what's called closed door drying. And closed door drying means at the end of the cycle, basically there's going to be basically a HEPA pump pulling. So there's an air pump right here that moves air through a HEPA filter, and then it takes it and actually pushes it into the chamber, and then it comes out here inside the reservoir. Okay. And this closed door drying, what it does is it allows for all the air that's drying everything to be filtered out with the HEPA filter, so there's no germs getting into it and getting onto the packs. Now, let's see. So it looks here like I can hear it heating. We're at 90 degrees, so our temperature's going up. As I'm talking about other things relevant to autoclaves, with regard to sterilization, and it's important that you will run through a full drying cycle of about 30 minutes on these style of autoclaves in order to make sure all your packs are completely dry. There's a phenomenon called the wicking effect. The wicking effect says that on a sterilization pouch, like something like these, the sterilization pouch has basically a plastic side, so you can see what's in there, but it also has a paper side. And when you're running these packs, it's important that they're completely dry when they're coming out before you handle them. And the reason is because when the paper's wet, germs can actually travel through the paper on the moisture. So the wicking effect is something that you can look up and kind of learn a little bit more about it. But the drying cycle on these autoclaves it's not a good idea to just skip it or forget about it, because the drying cycle is one of the things that allows for your instruments to remain sterilized after your cycle. I have seen offices where they just put a towel out, they just take the things and they just like shake them out on there, and that's just not a best practice to do that. So right now we're at about 120. We're still raising the temperature there. Have we got any questions yet, Kyle?
Nope.
Nobody has any questions.
No.
What else should I talk about with regard to autoclaves? What questions do my men have? Are there any questions?
What causes things to go out of calibration?
What causes things to go out of calibration? Okay, that's a really good question. So, over time, electronic components can degrade and wear, specifically things like capacitors. Other times they can, like, I would assume, you know, as current's flowing through something, there can be like some sort of a thermal change. And as that thermal change is happening, there can be different resistances and whatnot. There's also there's probably a lot of reasons it could happen. That is good to bring up though, because in autoclave, it's important to recognize that in general you have some sort of a motherboard, some sort of a main board, and this is actually on most modern equipment. So over here, if you want to look, some of the things that we see here is right down there. That's the adjunct board. Up here, I think that's another. So that's the adjunct board. That's like that's a brain for the unit. Up here is another. I think looks like some sort of has some power function. Maybe that's that's handling some sort of power. Over there on the back, those are called solid state relays. So that guy right there, that has it's a relay. So basically, what a relay does is it takes a lower voltage and controls a higher voltage. So there's one of the solid state relays, I believe, controls the heating elements. The other solid state relay will control the pump. So that's how that works. You also have a display. So what I'm getting at is basically the control board. What that does is takes signals in from everywhere, and so it has inputs and outputs. So for instance, on this particular board, one of the inputs would be a pressure transducer, okay, because that's telling the machine what the pressure's at. The other sort of an input would be some sort of an input could be a temperature sensor, okay, so that's telling it what the temperature is inside the chamber. Another input could be like the door sensor, okay, they could be telling the board like, hey, your door's closed, your door's open. So if you think about a piece of equipment like this, like it's basically it has just a brain, and it's got all the little things hooked into it, and some things are going in, some things are going out. So with regard to troubleshooting equipment like this, if you can isolate what sort of problem you're having, that's going to help you understand like what likely culprit could be causing it. And I know like there's a lot of times where there's a problem, and like the first thing people want to do is like, hey, change out the main board, you know, because that affects everything. And you know, that's just not always what it could be. It could be the main board, obviously, but it could also be like the wiring. There could be a problem with the component itself. There could be some sort of a loose connection. There could just be all kinds of different things. Here, there could be an issue with the calibration. You know, how the things are calibrated. Every single component. This is actually so like here's the question, like why do we need to calibrate this? Every single component has a slight difference in resistance and how it responds, even if it's just a little one. So, you know, you might have like a wire that has just a little bit more or less resistance than the other wire. There might be a connection that's just maybe not quite as good. There's a little bit more resistance maybe on that connection. So that's affecting the voltage going through it. Ohm's law is, you know, has voltage current and resistance. So those things, all three, the Ohm's law, that affects everything, and how these work. So more resistance is gonna mean like less, or current, or however that is. Now, so what's happening is now we're starting to get pressure build up, and so there's this little doodad here, this little pressure vent. That's normal for it to be venting like that. It's designed to be kind of pulled and pushed and all that kind of stuff to clear it temporarily. There's also a safety valve here. One of the things Tootnauer recommends is to like pull that little grenade pin out and like test it periodically. I never touch it because once I touch it, it breaks. So my thought is, if it's not leaking, if it ain't broke, don't make it broke. So what's happening now is as pressure is building up, that pressure, again, through our manifold here, okay, that pressure's affecting everywhere. So we have basically our temperature sensor here, and then we have this manifold. So all this is getting steam in it. So here's our, now this is actually in circuit with the pressure transducer. So basically whatever this is reading is exactly what that's getting. And the reason that is because of Pascal's law. Pascal's law states that pressure in a confined space is going to be basically pushed out equally in all directions within there, but it's also that Pascal's law means that inside here, the pressure inside there is the same as out here. And that's how we can actually take something all the way at the end of this tube, okay, and know that that pressure is representative of what's inside the chamber. So that's why by putting a gauge here, I know now we actually have, an independent reference for what is going on inside of the chamber itself. So, and now we can start to compare this reading. So right now we're looking at it, and this is about like 8, climbing up to 9 psi. So we can look here and see what our pounds are. So right now we're at about 7, so we're maybe a little bit low. We'll see, and then based on, look at this. We can kind of look at this thing while we're doing it. So 225 should be about 4.3 pounds. So now I would just say this right here, I wouldn't freak out in the middle because this is, obviously this is science and this is accurate, but you just don't know, like the machine, these are not the critical values. The critical values are obviously 0, making sure that that's good, and then also the sterilization temperatures, which are going to be between 250 and 270 degrees. So right now 239 pounds. So it looks like maybe it's lagging a little bit, but we'll wait and see how it fares when it gets a little bit up here in these higher regions. But what we do know is that's 10, that's about 11. So that's good. That's what we're looking for. Our independent reference is matching there. So the calibration of this, we did the main part of following the book and doing it. Now the second part of the calibration is paying attention to the unit and actually making sure that it's functioning. What I found is that one possible thing to look out for is that when we get to that upper range, the pressure or the temperature might be a little bit too low, so that it doesn't activate the sterilization cycle, because I believe the sterilization cycle starts at between 28 and 30 pounds of pressure. So if the sterilization cycle is maybe like down there like 27, maybe it's just hanging out real low, we might tweak that TP2 and go ahead and bump it up just a little bit. What the effect might be that when it goes back down to 0, instead of 0, it might read like 1 or 2. So you might have to take like that whole thing and like shift it up and down in order to actually get the machine to work correctly. And that's one of the things that's not really fun about these, because it would be nice if we could just follow all these instructions and it'd work perfect. But it's kind of just a known issue with these, that you tweak it, you mess with it, you come back, and then you run it again, and you just hopefully you can get it running. If you can't, then one of the likely things that you do is you replace that Ajunk 3 board that we looked at earlier. So looks like we're at about 15. So 15 and 16. So we're going to see there. So 15 means it should be around 250. Oh, there we go. Look at that. 15.3, 250. So this saturated steam chart, there's a lot of them online. I think it's just a scientific thing, so you can find them different places. This is just one that I found and printed out. This is just super handy when you're trying to like explain why steam leaks matter. Now, one way that we can detect steam leaks, as we're talking about steam leaks, is through the use of a mirror. And I don't know if I have any mouth mirrors. Oh, awesome. All right. So by using a mouth mirror, you can hold a mirror over something, and basically it'll kind of like fog up if there's any steam coming. This is maybe not a great example, but because I don't think it's quite hot enough. But if steam was coming up and maybe you couldn't see it, the mirror is a great way to detect it. The other way you could detect it is just by holding your hand over. And specifically up here in the front of an autoclave, when you're running an autoclave, you should be able to hold your hands on both sides of the door, and you should be able to hold them there. If you ever can't hold your hand on the sides of the door, then what that tells me is that gasket that's in the middle on the door is leaking, and that's something that should be replaced periodically.
We do have a question.
Okay, awesome.
How do we know when our equipment needs calibration?
So typically the equipment, so the manufacturer recommends that the preventive maintenance is done every year. During the preventive maintenance, you should be running a thermometer. If your thermometer is out of spec with your display, like say you set it at that's actually what happened with that one. We put a thermometer in it, it read 260, but the display read 270. That caused me to stop and say, okay, let me go ahead and look further into it. Of course, that's a manual unit. With this one, the calibration is a place to stop, to start. The other thing that usually drives these calibrations is the fact that you have some sort of an error, some sort of a problem, it won't run. In dentistry, I will tell you, it's unfortunate, but it's true. Most offices are not really crazy about preventive maintenance. They won't do preventive maintenance just for the sake of it being the right thing to do. Most dentistry is, I would say everything with dentistry, just about everything with dentistry, in my opinion, is pain-based. So what happens is patients go to the dentist. Why do they go? Do they go because they want to have, to sit there? No, they go there because they're in pain or they don't want to be in pain. Then this equipment's the same thing. So when it's messed up is the time where this is a good thing to calibrate. I would not proactively, okay, so if you're I would say if your thermometer's good, I wouldn't screw around with this at all. You're more likely to cause a problem than you are to actually fix one. If your standard, right, your thermometer, okay, matches what the display is, I would go ahead and, sign your paper off and you're good to go. It's when there's a deviation or an error or something that's going on that's amiss, that I would run this. Now, I would say that if you're doing any of these sorts of repairs, the RPI kit is indispensable, because just being able to throw a gauge on and see where you're at is it's really important. And I mean, I wouldn't, this is just a gauge, so you could probably just go ahead and build your own setup. That's how a lot of these things are. But again, with RPI, I really like their setup, and I think we have one of these kits for Tutenauer, Minmark, and Skycam. So if you have these kits, it allows you to be able to do repairs to these, and also gives you processes to run, you know, with some of these other devices. Like if you're smart, you could probably figure out how to make this, but it's easier just to buy it, which is why I did. Hopefully that kind of answers. You think that was a good answer, Kyle?
Yeah.
All right.
We're at
What about you,
270.
Jeff?
I think it was a pretty good answer. I think it was a good answer.
How about that? Good answer. All right, awesome. Okay, so here we are. So right now we're at 29 pounds of pressure. We are at 274 degrees. 30 pounds of pressure. And we're set at 273. We're at 30. It should click over. It actually is sterilizing right now. Looking at this, okay, those two numbers to me are very healthy. All right, 30 pounds of pressure is great. Let's look at our saturated steam chart here just to double check. So 30, 274. No, that's perfect. And that's how come this chart is important, because the chart tells you, it tells you everything's okay. All right, you look at this, you look at that, you look at that. Now, we are maybe running a little high on the pressure side, but we'll kind of see what happens here.
I have another question too.
Okay, what's that?
How often do you calibrate your multimeter?
0 times. Sorry. I am a biomed by trade, but I will tell you, I have an electrical safety analyzer as well that I haven't calibrated in years. For those biomeds that are watching, because I can tell that's kind of a biomed kind of a problem or a question, dentistry is just crazy. I will tell you, like, one of the things is, right, this multimeter is probably a $40 meter from Lowe's. A lot of times the way I use my multimeter is I'm using it for go, no go. And this is, it's a good idea to get your equipment calibrated. I recommend it. I just honestly, truthfully, because I'm just telling you what I do not really calibrate equipment. I'll just buy another one, because with dental equipment, even though it's important to do it right, because you can do a flood or you can do a fire in an office, there's not really there's no life support dentistry, so it kind of falls into different, a lot of times we're just, again, it's pain driven. Doctors invite us in when there's some kind of painful, like they can't make money, like that's pain. And so, so I do not calibrate this meter. Would not be a bad idea to have some nice fluke meters, calibrate them every year. We're just not there. I'm sure you guys probably know, like, this is actually, this show happens, or this channel happens in the context of a business that's actually, like, that I made, that's doing dental repair in the Ann Arbor area. So a lot of these things are practical, and that, that's why I'm sharing this, because, some of this stuff I think is a good, it's just good to know. And, you can learn it yourself, by yourself, or, you can kind of learn it in the community, which is what, I'm kind of hoping to do here. So, as you can see, our gauge registered the pressure up there at about 32 pounds of pressure. It was reading about 31 on the gauge, and our temperature was good. Once this is over, and also it looks like it's going to actually pass the cycle. It's a good sign. The thing we want to pay attention to now is we want to make sure that pressure goes back down to 0. That's the drying phase that I told you about. So the pump is running. That noise is air that's coming in through the HEPA filter. We can tell it's coming in through the HEPA filter because if I block that, the noise is going to stop. All right. So, all right, and this should actually be replaced about once a year, because the preventive maintenance on these autoclaves, which is the door gasket, there's a bellows, there's the little silver
Air jet
valve, and then yeah, and then the HEPA filter. So again, these are also RPI kits. Can you get one of those RPI kits? All right, so we're at 0 pounds of pressure. Okay, we are approaching 212 degrees. I wouldn't really, like, I know it's 212 is kind of our number, but if you notice, that's kind of probably dancing a little bit between 0 and 1, or it was at least. Well, I guess the other thing to know is, okay, it's possible for the pressure to exceed 212 degrees with no pressure, because think about it like this. Your oven does it every time you cook something. So the point of the 212 to 0, 274 to 30, that is all about saturated steam, which I guess I should just kind of, reiterate. You should already know this, but if it's a refresher, saturated steam is really a non-destructive way of sterilizing instruments. But this is what the PM kit looks like for this unit. It's for an EZ10 and TUK 133. And again, inside the kit, there's going to be these things that, let's see here, pull them out, look at them a little bit while we're letting last minute. All right. All right. So there we have a new door gasket. Maybe if you guys chime in, we can maybe go through how to do a PM on video if you want to see that. So I dropped something.
Oh, is the PM sticker on the ground?
Oh yeah. All right. All right. So right here, there's like a little door safety switch cover that goes on the door safety switch. Here's our air jet. That's what that looks like. There's some chamber mesh filters, and then there's also this bellows that's inside the door. And then there's a HEPA filter right here, and then there's the gasket. And the other thing that's nice is for those of you that are starting to do these PMs, this PM checklist that RPI gives us is great. I mean, they just tell you exactly what to do in the right order, and it even tells you how to do those different things. So this is a great checklist, and RPI has a lot of really quality training information. So, all right, so cycle's finished. That's a really good sign that we were successful. All right, so watch. So as we open the door, all right, when the door switch is open, now the everything's back to the way it was. And there's our hot.
There's gloves down there.
Hot mama. All right, let me show how I do it. All right. So there we go. All right, so I'm gonna just see where we're at here. Ooh. Well, it would have been nice if that thermometer actually worked. It's so awesome. Well, so it's so
Put one on the board. You want another one?
yeah, we'll probably need to order that. Yeah. Oh my gosh. So this might be part of the lesson where. So what I would expect is for the temperature to be reflected right there in 270. because the pressure was up there at 32, I don't have any doubts that it got there. One thing that's important to know is that if your pressure is verified to be good, then your temperature has to be there where your pressure's at. These two numbers are like hardly correlated to one another. They're like, it's a fact. If you have 30 pounds of pressure, you have 270 degrees with the steam environment. If you don't have the right temperature, then you have some sort of pressure leak somewhere. Now, I think what might have happened with this, and I don't know, this is pretty sad. I'm kind of afraid what I'm going to see here. But why not? So we're going to look at this. I don't know. There's our mercury. Oh, never mind. Dude, I don't know. How come I couldn't see that?
Dude, this is possible to read.
All
Oh,
right.
yeah, there it is. I got it.
Can you see it?
Yep. 270.
What temperature we're at?
Like 269? 270?
That's 270 to me. All right. So I don't know why I couldn't see that. That was crazy. I couldn't see it. I'm just getting old, I guess. All right. So, All right. Let me put that back together just because if I don't, something bad will happen. Are there any more questions, Kyle?
Nope.
No. All right. So, all right. Well, there you go, guys. That is the full calibration of a Tutenauer without any significant errors. No mercury releasing into the environment. We're good to go. Please feel free to chime in. Any other questions? Please let me know if you like this format. It's a little bit of a longer video, but if you got nothing but time and you want to learn this stuff, I guess I can teach it to you. So have a fantastic week. Happy Monday, and we'll see you next time. Have a great day.